Let's go ahead and get started. My name is Sam Stewart. I'm a project manager here at the Data and Research Center, part of the All of Us Research program. This session is being recorded today, and we'll have it posted to our user support hub within the coming week. If you need closed captioning for this session, feel free to turn it on to the language that you prefer on your screen. So our agenda today for new user orientation is just to give you a high-level understanding of the All of Us Research program, the data access tiers we have available, and how you can use how the data is organized and how you can use the Researcher Workbench to start your project. We'll also go through a few of our support resources that we have readily available to you at the end of our session, and then we'll open up the floor for any question and answer. So we'll start with going over the program as a whole. What is the All of Us Research program and the data that we have available? So the mission of the All of Us Research program is to accelerate health research by enabling individualized prevention, treatment, and care for all of us. So the research program is currently inviting 1 million people from across the United States to help build one of the largest health databases in history. And our goal is to provide that rich biomedical data set to you as researchers so that it will catalyze your research and projects so that we can hopefully build on research discovery. We hopefully do that by the core mission that we have on your screen here, by nurturing partnerships with those participants. And then once we nurture that partnership and they share that information, we hope that it will then deliver that data set to you. And that will be a catalyst of biomedical research that helps community researchers and funders of the All of Us research program. We hope that All of Us will be an indispensable data set used across all research in the United States and abroad. And we hope to maintain this effort in our mission. So you might be saying, okay, how are you all doing that? We welcome participants from all backgrounds, and we engage with these participants who have been previously left out of medical research. And we have a lot of engagement efforts that allow that to be possible. We then hope that you all will utilize this on the Researcher Workbench to learn more about biological factors, lifestyles, and environmental factors that affect health. And then this may be kind of an entry point to allow more research for disease and treatment. One thing that we love about the All of Us Research program is that we follow our participants as they age, move, and grow. So as I mentioned, we are inviting 1 million participants from across the United States to be part of our data set. Currently, we have about over 800,000 participants that are enrolled. And of those participants that have enrolled, 574,000 have completed the initial steps of the program. So the initial steps of the program are consenting and agreeing to share, consenting to the program, agreeing to share their electronic health records, and then completing the first 3 surveys, which we'll talk about, providing physical measurements, and then donating at least 1 biospecimen to be stored at our biobank. We do have currently over 633,000 participants currently available to you in the Researcher Workbench to do data research on. We do have more information of the breakdown of our participants in our data characterization report that's on our user support hub. So next, I want to talk about the data set, our curation process, and the structure of our data set in the Researcher Workbench. So we offer many different data types in the All of Us research program to include survey information, electronic health record data, physical measurements, and wearable data. And you can see all the numbers here on your screen. I won't read them. So most of our participants have multiple data types. So once they consent into the program, they have survey data, electronic health record data, genomic data, wearable device data. And the participant ID for each participant remains the same across different data types. That allows you to have that continuity across the different data types so that you know you're looking at the same participant. We're very excited to boast that we have one of the largest Fitbit data sets available to researchers and one of the largest genomic data sets as well. We have increasing consent for electronic health record data, which is a nice pairing to both of those data types. So this image here is just providing an overview of our data curation pipeline, which may be of interest to you. So we at the Data and Research Center receive participant data from our partners. That participant raw data undergoes quality control in our curation process to ensure participant privacy. That data is then also harmonized and standardized to the OMOP Common Data Model when applicable. And then once all of that refinement has been done, we will then push something to the Researcher Workbench called the Curated Data Repository, or CDR. So if you're new to all of us, you'll notice that we will have CDR written on our support material. We're talking about the data set that's available to you in the Researcher Workbench. And then every time we have a release, we note it as a CDR release, meaning that that data is updated and available to you in the Researcher Workbench. The CDR is kept on a secure cloud platform, which is the Researcher Workbench, and we currently use Google Cloud Platform to power the All of Us Researcher Workbench. We do offer a data dictionary that might be really good for you to review. That data dictionary looks at the metadata tables that we have all of our data types stored in, so that when you are pulling data into the Researcher Workbench, you know what you're looking at and how the data is structured. So I did mention briefly that we standardize our data set to the OMOP Common Data Model. So the OMOP stands for Observational Medical Outcomes Partnership, and then CDM stands for Common Data Model. So the graph here just is telling you how we have mapped our different tables, whether it's electronic health record data, physical measurements, participant provided information via surveys, and how we arrange that table schema for you. So Odyssey, or the Observational Health Data Sciences and Informatics group, they manage OMOP, and we just apply OMOP to our data set. So Athena is a searchable database that is owned by Odyssey, in which it has all the available standardized vocabulary and concept sets that are used. Now, I will note that we may not have all of the available concept sets in Athena because our data set is just the participants in AOU, but a lot of those concepts are available in the All of Us Researcher Workbench. And we also have another resource on the User Support Hub that describes more about how to use OMOP tables, what those tables are, and their descriptions. The best source of truth is to go to Odyssey, the site themselves. They have a lot of information about how they have structured the data, and to learn more about the different OMOP tables. And we'll kind of go into details in just a bit. So this is kind of an example. I just wanted to show you all about basically how we structured the OMOP in All of Us. So All of Us participant data is transformed to OMOP from source vocabulary. So that source vocabulary is how it's inputted into the raw data. So if we have electronic health records, for example, they could be coded in ICD-9 CM or ICD-10 CM or different types of source vocabulary, but they could be saying the same thing across different vocabulary. So we did that harmonization for you so that you'll get one final standard concept code in one standard vocabulary, which that standard vocabulary would be SNOMED, for example. So for example, if I have a condition, type 2 diabetes, that may have been recorded as ICD-9 code 25.00, but then in ICD-10, it might be E11. But you're saying the same thing. We standardize that to a SNOMED code, which would be SNOMED code 44054.006, for example. But that's saying the same thing. So when you get into the workbench, you'll notice that most of the vocabulary is listed in standard vocabulary. Now you do have the option to look at vocabulary in source if you want to. I will kind of note, if you are new to big data or metadata, it would be really helpful to learn more about the structure of All of Us before jumping into a project so that you can have more awareness of how the data is going to read back to you when you're working in the workbench. Next, I'm going to kind of go over how we at the All of Us Research Program protect participant privacy and then specific policies that you all must uphold while using data in the Researcher Workbench. So we do want to share data about our participants widely, but we also want to use their data wisely. So we've created multiple tiers of access. So the public tier is available on our Research Hub at researchallofus.org. And there's a couple fun things on the Research Hub to include our data browser. That just shows you aggregated high-level data that we have available in aggregated sums of 20. So if you're curious, like, oh, do they have information on this condition? Or is that specific variant available in All of Us? The data browser would be a great first stop. If you just are new to All of Us before you get a Workbench account, you can browse that easily and freely. The next two access tiers are once you have registered for the Researcher Workbench, you have two options for access tiers, registered tier and controlled tier. So both tiers require a specific level of data access requirements, but the controlled tier has an extra layer of training that must be completed to get you specific data available in the controlled tier. We'll go over each tier and what data is available in just a bit. So there are several ways that we at the All of Us Research Program protect our participants' privacy, and that's something that's very important to us. So our privacy experts have created a curation methods that have removed all personally identified information about our participant records. You'll also note in specific parts of the registered tier and controlled tier, some fields are going to be removed or suppressed or generalized to reduce that re-identification risk. Another thing that we also do is do some data transformation. So sometimes we have date shifted specifically in our registered tier. While that date shifting is consistent across all the data types, we've shifted the dates in the registered tier where if you do extra training for the control tier, you'll get the dates as is. We also make some generalizations about some demographic information to also protect our participant privacy. To learn more about our participant privacy, if you're interested, you can scan the QR code. We do have an article that goes into the specific details on what's available in the registered tier and what is available in the controlled tier in certain field options. So as part of your agreement to data user code of conduct, you will adhere to a few of these policies I'm going over. This is from our data and statistics dissemination policy, but we do want to kind of just go over the policies that you must do as a user of the Researcher Workbench. We've crafted these policies, and one of them include you cannot share participant row level data. That includes any data that constitutes an N equals one. One participant may not leave the Researcher Workbench. This includes any screenshots, copies, or download or written text about that participant data. If you would like to show data about the All of Us Research Program publicly, they must be in aggregated buckets of 20 or higher. And for allele counts, they must be 40 or higher. Now, we do have a count of 0 permitted. So let's say you don't have anything, you can put 0. It has to be 0 or 20 or greater. If you have questions about that, you can email us as well. So in this slide, we're going to review some data figures that are in compliance and then some that are not in compliance with the policy I just mentioned. So again, you must have your aggregated statistics to be more granular than 20 individuals. Outside of that information cannot be distributed without approval from the All of Us Research Program. So here on the top of your screen, we just had a quick chart where that N number is 17. That would be out of compliance with our data and statistics dissemination policy. But if you notice at the bottom of that screen, we showed a way to comply with a policy in which you can still denote that is less than or equal to 20. You just can't put exactly 17. Another thing we want to note is you cannot have it in your graphics where it can be back calculated to a count of 17. So not only did we change that first row, we also changed the total amount as well to be less than or equal to 44 instead of that 41. Here's another example of how to remain in compliance with our policy. So that first section over there had that bar chart with less than 20 in that age range. In order to comply with policy, we would recommend that you kind of stack the ranges a little different so that there's no N number less than 20. Now, we know that that's a lot to keep in mind, so we've created a publication, presentation, and poster checklist for you on our User Support Hub so that when you're ready to share your findings that you learn in the All of Us Research Program, it allows you to remain in compliance with our policies while also making sure you check off all the boxes. Now we're going to go into registered tier data. So within the registered tier, we offer electronic health record data, survey data, physical measurements, and wearable device data. And we're going to briefly look at each of these data types in turn. So within the All of Us Research Program, our participants do provide information about themselves in the form of surveys, or you'll note that I'll say PPI or participant provided information. So there are about 10 surveys that we have available in our curated data repository. And these questionnaires are often sourced from well-known national studies. So the first surveys that our participants interact with is our basic survey, then lifestyle and overall health surveys. So we kind of consider those the core surveys. Um, and then they have the option to take all of the other surveys, such as personal family health history, health access and utilization, social determinants of health. We just recently introduced the emotional health history and well-being surveys, as well as the behavioral health and personality surveys. And then we have some surveys that we did solicit during the pandemic, during about COVID-19. And so some advantages about using our surveys is that they're questions based on existing validated instruments for survey collection. And most of our surveys, all of them are translated into Spanish. So participants who speak either English or Spanish have the option to take these in the participant portal. Now, there are some limitations to our surveys. So within a given survey instrument, the participant has the option to skip any questions to include any branching logic questions. So you might notice that they might have submitted 4 out of 10 questions because the participant has the autonomy to do that. Another thing to note is that even if they take the basic survey and our other core surveys, they may not have taken the other surveys as they became available in the participant portal. Our survey questions and answers are transformed in a structural way to meet that metadata standard we talked about earlier via OMOP. But we do have a survey code book that has all the variables available for each surveys and how it looks to the participant and how it will read back to you in the Researcher Workbench. One thing I will note that we have a featured workspace, which I'll show later, about how to work with survey data. That's a great thing to look at because right now our All of Us data set is in long format. So you'll get a row for the same participant per row. So you might want to transform those surveys to wide format where it's one person ID and then columns of all the survey information. So the next data type we're going to discuss is physical measurements. Physical measurements include blood pressure, heart rate, height and weight, body mass index, and waist and hip circumference. So as part of the enrollment process, participants are given the option to attend a in-person enrollment site visit in which they will collect the physical measurements there, or B, they can provide their own physical measurements where they self-reported physical measurements. Both of those options will be in the measurements table in the Researcher Workbench. And then if they don't have measurements those ways, you can supplement measurements from the electronic health record data. So that's a few different sources of physical measurements. One of the limitations is that the physical measurements units in the EHR, you will have to do that normalization on your own. Sometimes EHR records measurement units and operators differently per source, so you'll have to kind of look at that. Also, self-reported measurements include only height and weight, where enrollment site visits have some more information like the body mass index, hip circumference, waist circumference, etc. So you'll just need to look at, was this from an enrollment visit or was this self-reported measurements from the participants? And we have a featured workspace as well that kind of shows you how to look at the differences. The electronic health record data is one of our most popular data types available on the Researcher Workbench. So at the time of enrollment, participants can also consent to allow EHR data to be part of, to allow all of us participant access to the EHR. Now, I kind of want to denote something here. Consent to the All of Us research program is not synonymous with consent to allow EHR sharing. So they'll have consent to the program and then consent to EHR sharing. So you might notice that we have over 600,000 participants in the Researcher Workbench, but that means that they have consented to the program and at least completed the basic survey. And then you'll see a little bit decreased number for EHR because some participants may have not consented to EHR. Now, EHR has a great advantages. So our EHR data is spread across about 14 plus OMOP relevant tables. So that data dictionary I mentioned earlier will be a great source to look at how we organize our EHR data. So we have EHR available from the entirety of the participant's life if they were enrolled with their HPO site. So if they've been at that health provider organization since infancy, once they consent to allow that EHR, we will have that information. Or we will have it as much as we have available from the HPO site. So one thing that I want to note limitations in terms of our EHR is we currently do not have free text clinical notes or imaging at this time. And then again, not all participants consent to have their EHR available. And EHR data only records from the health provider organizations that are in partner with all of us. Now, we do have some participant mediated EHR where participants who were not close to an enrollment site or an HPO site were able to share their EHR with us. And we have a support article on that as well. Now, we'll look at this soon, but when you view EHR in the Researcher Workbench, you're going to see about 6 main domains. That's conditions, labs and measurements, observations, drug exposure or medications, procedures, etc. So we'll look into that in just a bit. The final data type I want to talk about for the registered tier is our wearable device data. So we currently have wearable device technology from Fitbit. So Fitbit devices provide information about heart rate, summary statistics, steps, sleep, and that includes minute level data, summary data, and daily count data as well. It also shows more about the device. We added that at an off cycle last year about what device the participant is wearing. So there's a lot of advantages because Fitbit data is very longitudinal. You can go as far back as 2009 for Fitbit data for our participants. We did have a bring your own device for our participants, but we had a study called the WEAR study in which we had about 10,000 participants be provided Fitbits, like the one I have on here, to be part of the All of Us research program. So we also have that information. Now, I do want to note how our data for Fitbit is structured is a little bit different. So we have all of us specific tables for our Fitbit data, and there's about 7 tables. That's the step intraday, the heart rate summary table, the activity summary table, the minute level table for both the heart rate and sleep, and then sleep level data. And this is exactly how Fitbit shares it with us. So if you are new to Fitbit, we have a whole article talking about how to understand the way the Fitbit API shares data with all of us, and they construct kind of the concepts available in those tables. Another quick note about Fitbit and recommendation is that if you are choosing to use Fitbit data at the minute level, that is a lot of data. So be careful before getting started. Feel free to email us and we'll send you some resources to learn more about Fitbit before looking at minute level data. All right, now we're going to explore the options available in the control tier. So as I mentioned, there is more information in the control tier. So you'll get everything that we just discussed about the registered tier in the control tier plus more when you do that extra layer of data access requirements. In the control tier, you'll see that we also have available our genomics data set and expanded demographics about our participants as well. Another thing about our control tier data set is there's less transformations. So for example, the date shifting I mentioned earlier, instead of that happening in the control tier, you'll get the dates as collected. You'll also get more granular geolocation data. In the registered tier, geolocation is at the state level, where in the control tier, it's at 3-digit zip code level. So if you're interested in learning more, if you go to the article on the User Support Hub called Protecting Participant Privacy, you can see what's a little bit available in registered tier and what more is available in control tier. So the All of Us research program provides genomic data in the form of short-read whole genome sequencing data, long-read whole genome sequencing data, and microarray genotyping arrays. We also have structural variants as well. And I'll highlight on the next screen, we have some axillary files about these data types that might be helpful to use. So one of the advantages of our genomic data set is we're one of the largest and most comprehensive whole genome sequencing data sets available widely. I know we get compared a little bit to other data sets that are available, but we have quite a bit. One of the limitations we do know is there's no gene expression or protein level data available yet. Hope to come soon. And some phenotypes of interest may have some limited availability. The reason for this being is, remember, the next bullet point is not all participants will share their genomic data. They have the option to opt in or out of sharing a biospecimen. And we'll talk about this in a bit, but if you're new to genomic data, sometimes genomic data wrangling can be pretty costly, especially in computational costs. So if you're a veteran, you probably know that, but just kind of having a study design pipeline ahead of time will help you limit that computational cost. So we do provide some data formats readily available to you in the Researcher Workbench for our data set. our genomic data set. That includes, we provide the variant data set, which is the VDS, Hale metrics table, VCFs, we have BGENs, the Plink triplets, which are the bed, bim, fam files. If you are interested in raw data for our genomics data set, we have two forms. We have the CRAM and BAM files, and then for array, we have IDAT files as well. So a summary of our file formats can be found on the User Support Hub in an article called How the All of Us Genomic Data is Organized. It has a plethora of information about our genomic data set and what's available in each file. Alongside with the file formats that we provide, we do also provide an opportunity to use a variety of tools to assist you with your genomics analysis. That includes some workflow tools such as Nextflow, Cromwell, and then if you're new, but this is a great option, DSub, which is a command line interface that helps parallelize some of your workflows. We also do offer some of the most common R and Python packages. Hail is already readily available in the Researcher Workbench. We also have some other command-like tools, including JTK. And then if you want to use the terminal directly, you're able to do that. We also offer data prop clusters available in the Researcher Workbench. So that's a little bit more robust computational environment to use. And you can also run notebooks in the background if you have a long-running job as well. I did want to highlight or take some time to highlight that the genomic data set can be paired with any of the other phenotypic data types that we talked about earlier. And this is just giving you a breakdown. If you're like, well, how many people have genomics and this? This kind of gives you a breakdown of all of that. So you can see that over 28,000 participants have genomic data, EHR, wearables, survey data, and physical measurements. So that's quite a big in number if you want to look across all the different data types. The data characterization report I mentioned earlier has this information. Okay, so now that we've had an overview of the data, what's available, and the All of Us Research program as a whole, I'm going to transition into the platform and tools section of the Researcher Workbench. This is more looking at the functionality of what you can do in the Workbench. So what is the Researcher Workbench? So the Researcher Workbench is a cloud-based platform. And as I mentioned earlier, we use Google Cloud Platform to kind of power the Workbench. We provide several analytical tools, including RStudio, SAS Studio, and Jupyter Notebooks. You also have a bunch of graphical tool options to include our cohort builder and dataset builder. The thing about the Researcher Workbench is that we do a passport access model. What that means is that you can register with an institution that has a data use and registration agreement in place, but you do not need separate IOB approval, and you do not need to have a project in mind when you start your Workbench journey. So that's something that's really nice. You can have multiple workspaces at a time and work on multiple projects at a time. To learn more about the Workbench, you can scan the QR code, which has an article that gives a high-level overview of the Researcher Workbench. So I do want to highlight a few main sections about the Researcher Workbench to help you navigate the data more easily. So a workspace is where you're going to build and analyze your data set. And within a workspace, you're going to have two point-and-click tools, the cohort builder and the dataset builder. And we're going to go over those in turn soon. Within the workspace, you'll also have those analysis tools I mentioned, which are RStudio, SAS Studio, Cromwell, Jupyter, or you can just access the terminal as well. And then you also have quick access to the User Support Hub. There's a little icon at the bottom of the screen on the Researcher Workbench that if you have a question, you can email us at any time or get access to the User Support Hub to learn more. Now, this is a typical lifestyle of a project within the Researcher Workbench. I do want to note, depending on the scope and framing of your study, so additional steps and timings may be required. But essentially, you'll create a workspace, and then you'll use the point-and-click tools to query data. Or if you're familiar with our data structure, you can use a customized SQL if you would like. Then you'll choose your application of choice, whether that be Jupyter, RStudio, SAS, or a combination of all of them to analyze the data. Then evaluate your results and draft your manuscript and share your findings, as long as it's in compliance with our policies we mentioned earlier. A nice thing is you can add collaborators in any of your workspaces at different tiers of access. So you can add them as a reader, a writer, or an owner to your workspace, which allows easy collaboration. We do want to note they must have their own Researcher Workbench account to be added as a collaborator. You can't share accounts. So as long as they have their own account, you can add them. And this is really nice. So let's say that you want to kind of oversee the study design, but you have a data scientist that can help with, or a biostatistician that can help you with some of the data wrangling in the notebook. You can add them and you guys can collaborate together in a workspace. Now, before you can begin, you do have to create a workspace, and that includes writing a description of your project. So a meaningful workspace description is one that fully answers the question of who, what, how, and why of your research project in just plain language. The information you provide here is publicly available on our Research Hub under our Research Projects directory. So this is just an example, but just having a title that's reflective of your research purpose, articulates your research question, addresses any populations of interest you're looking at, and a layout of your analytical approach is very helpful. There are some examples on the Research Hub that show you how other people have filled this section out. That being said, you can come back and edit it at any time. We do understand that your project takes its own life once you start researching. So if you need to make some edits, you can edit it at any time. So I'm going to go over really quickly the high level parts of the Researcher Workbench. Then I'll do a quick demo so that you can see it live. So once you successfully log into the Researcher Workbench, you'll be brought to a landing page. And on that landing page, you'll have an option to create a workspace. If you already have workspaces created, you'll see those workspaces that you recently interacted with on the landing page. And then you have a blue icon at the top that says workspaces, and you can click that plus sign. A couple things to note on the landing page is that your workspace tiles tell you a lot of information about the workspaces. So the orange CT shield means that's a controlled tier workspace, and you must have controlled tier access to look into the workspace. There's another blue tile that indicates if a workspace has been published. What that means is if the workspace creator and owner publishes the workspace as a community workspace, that other Researcher Workbench users can view your workspace as a reader. When you are ready to create your workspace, you will log in, select the blue sign next to workspaces. You'll write your project's description, as I mentioned on our last screen, and then you'll go to create a workspace. We do have a step-by-step guide on how to do this on the User Support Hub at the link on our screen here. So once you have created a workspace, there are three main tabs: the Data tab, the Analysis tab, and the About tab. So I'm looking at the Data tab here, and underneath the Data tab, that's where you're going to see those 2 point-and-click tools I mentioned earlier, the Cohort Builder and the Dataset Builder. So the Cohort Builder and the Dataset Builder allow you a point-and-click interface to go ahead and pull your participants of interest and concepts of interest to export out into your analysis tool. It's basically just creating the SQL query for you. That's really helpful if you're not familiar with how to do that. It also just makes it more interoperable, so you can see like, okay, this many participants have this and this many participants have this before you actually analyze it in your notebook. So those steps, which I'll show you in just a moment to do that, is under the Data tab, you'll select the blue icon next to Cohorts. You'll select your inclusion or exclusion criteria about your cohort, and then you'll create your cohort and click Save. So once you create your cohort, it will always live in your workspace and you can interact with it at any time. The dataset builder is the next part of this, and the dataset builder provides you an opportunity to add concepts about your cohort. So if there are specific variables or values of interest about the cohort you just created, that's where you will use the dataset builder. So going back to the cohort builder is just pulling the person IDs. So we have over 600,000 participants. Think of the cohort builder as grabbing 1,000 of those people. And the dataset builder is going to give you more information about those 1,000 people that you just kind of siphon down in the cohort builder. So again, under the data tab of your workspace, you'll click datasets, select your cohort, and then concept set, which we'll go over in just a bit. And then you can even preview the data frame before you export it out. And then you can make applicable changes as well. Once you create your data set, then you're ready to do your analysis. So under the analysis tab is where you're going to see any tools that you're currently working, whether that's a Jupyter Notebook, an R Studio session, SAS Studio, etc. It will all live under the analysis tab. Just note, like, for example, once you create a notebook, if it's under the analysis tab, even when you shut down your environment, that notebook will still exist. I will kind of go over for R Studio and SAS. It's a little bit different to export the data, but I'll show you guys how to do that in just a moment. So the analysis tab is just showing you all the available notebooks that you have or your colleague has created, and that you can interact with at any time. So all of this, starting at the analysis tab, is when you're going to start incurring cost, because you're going to spin up an environment to interact with Jupyter SAS or RStudio. So I'm going to do a really quick demo so that you can see all the things that I was talking about related to the last few slides. So here on your landing page, you'll notice that if you haven't created a workspace, there'll be a tile that says create workspace here, or will be empty. You can create a workspace, and when you do, you're going to give it a title and you're going to choose your access tier. Now, if you only have registered tier access, it will just say registered here. But if you have both tiers, you'll have the option to choose. And then you'll choose which dataset version you all want. In the current environment, you'll see that we have dataset versions from one of our earliest versions all the way to our most current version, which is V8. And then you will choose your billing option. Everyone gets $300 of initial credit. So once you're new, you don't have to do anything with billing just yet. And the next few questions is where you're going to fill out that meaningful workspace description. And so, and you can come back and edit it at any time. But once that's done, you'll select create workspace, and then your workspace will be created. So I already have a workspace that's created that I can show you all. So here in the workspaces is where you have the data analysis and about. So the cohort builder is here and the dataset builder is here. So under the cohort builder, you can add specific criteria. You can enter a keyword search or go through and just kind of search through these different domains. Program data are participant provided information that we have about our participants, to include any genomic information that we have. The domains are from the EHR data, and then concept sets. Let's say you created a concept set and we want to use that for your cohort, you can. So if I wanted to search hypertension, for example, you'll notice that the keyword search hypertension brings back a few different data types: survey data and electronic health record data. And this is the condition occurrence table of our EHR. So you can select the specific criteria that you would like. For example, hypertensive disorder. You might have just noticed it selected a bunch. That's because of the hierarchy here. When you get more familiar with OMOP, you'll notice that there are something called parent and child codes. So hypertensive disorder is the parent code for benign, diastolic, essential hypertension. All of these are different types of hypertensive disorders. So if you don't want all of these, you can just unclick them if you would like. And then once you choose your concept that you would like, you would just select criteria and then save, and then you can add additional criteria. So there's a couple things I want to note on this screen. You have an OR operator or an AND operator. If you select the OR operator, meaning you go here and add other criteria, it is going to pull participants based on this concept or this concept. If you want to include both, you would then put one concept in group 1 and then another concept in group 2. So let's say I wanted the age to be between 18 and 45 as their current age. I would add that selection, save criteria, and what you'll notice is that the total count will change here. So this is the total amount of participants that have hypertensive disorder in their EHR and are in the date range of 18 to 45 as well. Now, these height charts are just there to help you kind of see and gauge how your cohort is structuring up by race, gender, sex assigned at birth, or other self-reported categories. Once you're finished creating your cohort, you'll select Create Cohort, give it a name and description, and it will automatically save. I've already created a cohort, so we'll go over to datasets. Now, datasets, I created this cohort earlier. So I would like to create a dataset about my cohort, and that's what this dataset builder is, and it's in a 3-step approach. You're going to select your cohort. We've given you a prepackaged cohort of all participants. Let's say you just want to do all participants, you can, or the specific cohorts you just created. We've also given you prepackaged concept sets. Let's say you want to have just demographic information about your cohort, you can, or you can select your own specific criteria. So I still want to look at hypertension per se. And I'm going to still look in the same conditions and add hypertensive disorder, finish and review, and save concept set. So I'll create a new concept set called hypertension and then save. When I go back to the data set builder, I will go to create a data set. I'll have my cohort that I created earlier. I can select demographics, and then you'll notice that the concept set I just made about hypertension is available here. And it'll bring up a new table. So you can select preview to ensure that you have what you would like to pull in. So the preview is a great option because I am pulling data from two different types of tables, demographics from the person table and conditions from the condition occurrence table. And they're going to pull out two data sets out to your notebook or RStudio, whichever one you want. And sometimes seeing it in this view is a little bit helpful to ensure that you've captured all of the variables that you want. Now, this last column will not populate until you choose a concept set. And you might not need all these values. These values are the columns like we see here. So we chose all our rows. Now we're looking at our column. Like I might not need the gender concept ID or the concept IDs for race. I just want it to list the name. And I might not need any source information about my condition. So I might pull all of those away and then go back to preview table and we'll update there. Once everything looks good and you're ready to go, you'll go to create data set and then give it a data set name. So let's just give it a name and then I'll call it 404 and then save. And it'll switch over to analyze. That means this data set is ready to be pulled into your application of choice. So you can select analyze and choose your programming language. You can use Python, R, or SAS. If you want to use Jupyter Notebooks, it's really easy. You can just create a new Jupyter Notebook or go to an existing one. If you're using RStudio or SAS Studio, what you'll need to do is go to C code preview. You'll have to copy that to the clipboard and then go into an open active application and paste there. If you're using Jupyter, you can export directly. So that leads me to this view over here. So I'll go to the analysis tab. So the analysis tab is going to house any applications that you currently have. So I just have one Jupyter notebook, and this is a really great option so that you can kind of look at what you have available. So here, I just want to look at, I have two applications running. I have Jupyter, and this is the cost per hour, and RStudio currently running. So this is for my Jupyter environment. I've created a standard environment at these configurations, our default configurations, and it's currently running. So that means that it's currently charging me computational cost. The same with RStudio. RStudio, you can't customize the compute profile, but you can see the cost while it's running here, and you can open it or delete it at any time. We don't have time in today's session to go over what all of this means in terms of CPUs, RAMs, etc., but we do have a support article that gives you a high-level overview of what the cloud analysis environment is and means. What this essentially is saying that I am interacting with Google Cloud at this point. I've created a virtual machine that I can interact with. And I'm going to show you what that looks like. So I have a environment running for, and this is my Jupyter notebook. I'm going to actually restart the kernel in a minute. So these are the code that I pulled from or generated from the cohort builder and the dataset builder. And it's pretty long, but it just basically created a SQL for you. I ran the query. I'm using R right now because that's showing you that in R kernel. And then you'll see a data frame here of your data set that you have. Now, this is just the raw data set that you pulled. I haven't cleaned it or wrangled it. It will come out into this dimensions or these tables. It'll only include the information that you asked it to include from the dataset builder. And then I have two code chunks because the first one was demographics information from the person table. The second code chunk is pulling the conditions from the condition occurrence table, and that's why I'll have a separate data frame here, and that's talking about the conditions that I pulled. And if you want to put those tables in the same, you'll use a merge function to merge the two tables. You can merge off the person ID and then create one final data frame for cleaning. I'm not sure if RStudio will open for me, but I'll just show you RStudio if it does open. It looks much like the RStudio you see if you have a local RStudio. It's the same, just in the cloud. So if it opens up, you'll see all the console panels. Yep, there you are. So you'll see all the consoles. And if you need to run anything, we have a full support article on how to interact with it. But this is where you would kind of you can just add an R script here, and this is where you're going to add in all of your code that I just mentioned in the dataset builder. You have to copy to the clipboard, paste it, run it, and you'll get the same output as I did in the Jupyter notebook. And then I wanted to highlight really quickly that you also have options to go to something called featured workspaces. Your featured workspaces are tutorial guides that have code that show you what to do. So for example, if you're new to coding, start with the beginner intro to the All of Us Researcher Workbench. It will show you different notebooks that we have available about learning OMOP, exploring, how to query data using SQL and data manipulation. So our featured workspaces are a great place to go. All right, I'm going to continue in the interest of time. We have a bit more to cover. So quick, couple notes about cloud computing and billing. As I mentioned, the CDR is securely contained within Google BigQuery. So to interact with that, you need to use SQL. And so depending on how much data you're pulling, you're going to incur some cost for that. But you'll use a CDR variable called workspace CDR if you want, or name your own variable, or you can use the explicit CDR name. If you're using the dataset builder, we do this for you. You just have to run the query and it'll pull as you need to. So that's kind of what's happening behind the scenes when you interact with the data set. As you guys saw, those green dots I had, those are cloud analysis environments. If you're new to cloud computing, basically the Workbench uses Google Compute Engine for computational resources in the cloud. And so basically we've created a virtual machine that allows you to interact with our Google BigQuery server to pull in the curated data repository into a secure way that you are locally working on your local VM in the cloud environment. So for Jupyter, we use Google Cloud Engine. For our Studio and SaaS, we use Google Kubernetes Engine. And then that allows you to connect both to Google and to your application of choice. We have something called storage options, which I wanted to go over. Currently, for standard environments, we provide persistent disk, which is like is a good permanent storage option. If you're used to them, it's like a reattachable USB. Every time you spin up a standard environment, it will automatically attach a persistent disk. If you don't want to use that for long-term storage, we highly recommend that you delete it. And then the workspace bucket is where you should do everything. So the workspace bucket is Google Cloud Storage. We just note it as workspace bucket. And you can interact with that at any time using a gsutil command. Overview of cost. I'm going to spend some time here. So your cost is the amount of data you're pulling in from BigQuery, the amount of compute resources you're using in your environment, how much time you're spending, and then your storage. So let's say that you have a really big cloud analysis environment running for a long period of time. You're going to incur some cost. But if you want to have a more robust environment, but do it in a shorter time, you might cut down on cost. It just really depends on what you're doing. Now, this is not including any workflow tools you're using. So if you're using Cromwell, Nextflow, or DSub, you have to add in some cost for that as well. And then your storage is the use of the persistent disk or how much storage you have in your workspace bucket. So as I mentioned, but don't fret, we give you $300 of initial credits when you register, and you can use that to pay for your environment, your storage, and the data pool. But once your credits expire, you will need to add a Google Cloud billing account, which we do provide a stepwise guide on how to do that. Now, I do want to note, if you are going to start with a huge genomics analysis, you might want to go ahead and get ready to add your Google billing account on the front end, especially if you feel like those costs are going to go over $300. That way, it's no interruption to your analysis. Tips for minimizing costs. So pull less data when possible by using the cohort builder and the dataset builder. So just kind of refine your query a little bit more, kind of feel out what you have, start small and scale up. Test your pipeline on a smaller data set. Save your files to your workspace bucket over your persistent disk unless you're used to using persistent disk. And then if you do not need your environment for a long time, go ahead and clean up your environments and delete them at the end of the day. It's kind of like turning the lights off at the end of the day. Just turn off your environment to prevent you from spending costs. And I have given you all a lot of information in this last hour, so I wanted to provide you some support resources. We do offer the User Support Hub. Myself and a few of my colleagues have this huge knowledge base for you all. And so it has step-by-step guides, tutorials. We even have an event calendar for other virtual events such as this one. We do offer a virtual help desk as well and weekly live office hours. There's also a community forum. So there's other researchers who are kind of veterans to all of us that post their workspaces or tips and tricks on the community forum. We do offer, again, I mentioned some sessions available to you. We do host Tuesday office hours, which is really nice because it's with myself and the data science team. So if you have live questions that you want to ask, and you're saying, hey, can I show you my workspace? What does this mean? That would be a time to come. We offer new user orientation every month, such as this. You can join as many as you want. And then we also host bi-weekly Friday office hours. During that office hours, it could be a researcher presenting their study or finding, or someone from our team providing you best tips and tricks. Again, I'm just highlighting the community forum because there's other researchers like yourself on the community forum. So they provide sometimes they even provide their code, or they just want to collaborate with others or receive support. A quick note about the community forum, you do have to be logged in to your Researcher Workbench account to access the community forum. But if you scan that QR code, it has a stepwise guide on how to do that. So if you're like me and you are a visual learner, the video tutorials will be great for you. We have a few workshops we've done in the past posted to our YouTube channel. We have some navigation guides as well also how to use SAS in our studio. We had a few members of our data science team demonstrate how to use both of those in the Researcher Workbench. So you can go to support at researchallofus.org to kind of see all of that. And we do continually update our videos over time as well. And lastly, if you want to keep up with the All of Us Research program, funding opportunities, or just new and improved events, sign up for our Research Roundup newsletter that comes out every other month. And in the last few minutes, will take any questions that you have.